And welcome to week 6, day 2, the day in which we get to build our own MCP client and MCP server, MCP being the USB-C for AI. And I just realized this picture actually shows USB-A for AI. I imagine a bunch of people are going to point this out to me from the last time I showed this picture. Sorry about that, but this picture is showing what it could be without having MCP, which is of course our USB-C for AI. Anyways, moving on, let's get to it. As usual with these new things, I like to bring up the same material a couple of times to really drive the point home. The 3 pieces of the puzzle of MCP: the host, which is the app like Claude Desktop or our own agent platform; the MCP client, which is inside the host, and there's an MCP client for every MCP server; and the MCP server is one particular grouping of tools, contexts, and prompts made by somebody that we can reuse. And I gave the example there of using fetch as a way of running a headless browser. Okay, and then also a reminder of the architecture. This is a more busy diagram, but hopefully one that's quite familiar to you now. So the host, the blue box there, runs a number of MCP clients, and I talked about the 3 different approaches. The first of them, that first yellow box, is where an MCP client talks to an MCP server that is running locally on that box, although in a different process that was typically sort of spawned by the MCP client. And they connect over standard input and output for that process, and it's known as a Studio or STDIO connection. And the second yellow box is very similar, another MCP client running in the host, connecting to an MCP server in a different process on the same box. But it's just to show that there will frequently be cases where that MCP server is in fact connecting to a remote server to carry out an API. Just that's what the code does in that MCP server. Maybe it calls out to Google's weather API. Maybe it calls out to Slack. Whatever it's doing, it happens to have an internet connection. So basically, the first two orange boxes are basically the same thing, just one of them happens to use the internet. But the third yellow box is a different architecture, and this is where you have an MCP client that's calling out to an MCP server running remotely, and there you would have to use the SSE type of transport, the server-side events, which allows for, it would do an HTTP post to send the message out, and then it would receive back the information streamed back using the SSE approach. And this is less common generally in MCP land, at least as of now. It's not so common, but we will look at it at one point. But most of the time you're running the servers locally. And with apologies for the repetition, but sometimes it helps to repeat, just like in prompting, it helps to repeat that when you're explaining things as well. But with that, what we're doing today is mostly making an MCP server, and we'll also make an MCP client, but that's a little bit of a red herring, as I'll explain. But this is mostly what we're going to be doing, making an MCP server. And the question is, why does one do that? Why do you create an MCP server? And the main reason you do it is for sharing. You're doing it because you're going to publish your MCP server somewhere and allow other people to incorporate your tools and resources and maybe prompts. Seems less common, but your tools mostly in their projects. That is the reason, the primary reason for making an MCP server. Also, if in your project you're using a bunch of MCP servers yourself that you're sharing, maybe you'd like to be consistent in terms of how you arm your LLM. So you'd like to have your own MCP server to combine it with all of the others. And it's also worth doing it as an exercise to understand what happens behind the scenes. Building our own will help to reveal the bits and pieces that make up MCP servers. But there are some reasons not to make an MCP server, and there's really just one of them I wanted to highlight, which is that, look, if we're making this just for our own project, for our own purposes, so we've got some tools and we would like to use them with our LLM, then remember, like, it's actually really easy these days just to make a function into a tool. Back in the day, you needed to have all of that stuff around turning that JSON gumph. But these days, if you're using OpenAI Agents SDK, you're just putting an app function tool decorator over your function, and then it's becoming a function tool. It's a tool right away. You can just pass that in as a tool into the agent. So it is quite easy to do this. And this is certainly something that is worth keeping in mind. It's not particularly worth building an MCP server just if it's only for your own personal use internally. And you might as well just use a function tool decorator. So keep that context in mind as we launch into this. And it's great to be back in Cursor for this big moment of making our own MCP server. All right, we're going into folder 6, of course. And first of all, well, let me just bring you to the lab. Here we go. So week 2, day 2, about to create and use our own MCP server and client. I do want to make the point that whilst this is pretty simple to do, it's not like it's incredibly straightforward. There is going to be some stuff. And the important thing to do is less about the magic of MCP is less about whether it's easy to make your own server. It's more about how easy it is to share and use other people's servers. So keep that in, again, that context in mind. The first thing we're going to do is go and look at some code in a Python module called accounts.py. And this is a code, this is a module which allows you to manage transactions. It will keep track of transactions for different people who are buying and selling shares. It's got a class account, and that class account has account name, a balance, strategy, holdings, a list of transactions, and a time series of the portfolio value. So there's quite a lot to this. And it's an interesting piece of code. You can buy shares, you can sell shares, you can calculate the portfolio value and do some other things here. So a nice little utility for managing, buying and selling shares and maintaining an account. And maybe you know where this is going, but if you could cast your mind back a couple of weeks, this, of course, this is the code that was written by our engineering team of agents. This is one that is the fine work of our backend developer, our engineering lead, and somewhere there's also a test class to test this as well, and it's being tested. Now, of course, I've added in a few details here and there. I actually put in that time series thing. I added in the strategy of the portfolio. So a couple of things I've just gone through and added in. And I think I did find a small bug that I had to fix as well. But generally speaking, this code was written by our engineering team of agents in Crew Week. And so this was the result of week 3. And so if you skipped week 3, then you missed out, because this was really cool, really fun. And you could see how to build an engineering team that writes code like this, builds a whole module and tests it on your behalf. The other thing I've added at the very top of it is I just put in some SQL, which I hadn't asked for in the original requirements, so that an account can be written and read from a SQLite database. But this is just Python code. This has got nothing to do with MCP, but it's a little tool, a set of tools, some useful code that we have written, or, well, we haven't written it, that our engineering team has written. And we want to now turn this into an MCP server. So we want to build an MCP server that can expose this functionality as tools with descriptions. So imagine you just got this off the shelf from your team. It's time to turn this into an MCP server. So this module was called accounts.py. And for the MCP server, I'm going to take you to accounts_server.py. So again, this is us building our own MCP server to take advantage of this code in accounts.py. And here it is. It's very short, and it's mostly natural language, as you might expect. It's text, and it's wrapper code to wrap our Python code. But you could equally well just have the Python code right here. Like you don't need to do it the way I've done it, but I've kept them separate so you can clearly delineate the business logic in accounts.py from the MCP server in this accounts_server.py. So this from MCP server fast MCP, import fast MCP. This is Anthropic code. This is nothing to do with OpenAI Agents SDK. This is MCP code, a way to quickly build your own MCP server. And we are then importing our business logic accounts. We're importing the class account that was set in that package. And as I say, equally, you could just write the code right here, but we're separating out the logic. So here's an example of a tool that we want to make available through our MCP server. And it is pretty simple. There's very little to it. You put a decorator, mcp.tool, like that. And then here we have the function that is going to become our tool. It's async. We give it the function name, of course. And then this is the one parameter. We have docstrings to say what it does, and we use docstrings to state the parameters. And then this is the logic, which in our case is just delegating to our business logic to get the name and return the balance. So that will become a get balance tool given a name. It will create a new account or it will access the account for that person and get their balance. That's the tool. This is it. With this, we could just stick with get balance, and that could be our MCP server. We're going to add some more functions, but that's all there is to it. So then we're going to have like get holdings, which just does the same thing for holdings, buy shares, which does the same thing, sell shares, and then we've got a resource at the end of it. So as I explained, MCP servers have tools, resources, and prompts. We're not going to cover prompts because they're just not that great to use, but it's a very similar concept to this. But we've shown tools and used sometimes as resources. And with resources, you have like a URL kind of construct that describes the resource that will be asked for. And I'm suggesting it's there's some discretion as to how you do this. You sort of put here what kind of thing are you talking about, and then your MCP server, and then any arguments. So in our case, we've got a URL we've constructed here. If someone looks for account server, and then passes in someone's name, it will look up their account and return a report of it. So that is it. And if this is run, then it just calls mcp.run, and it selects the transport as standard input output, the basic simple type that you use for local MCP servers. And this is it. This is building your MCP server. That's all there is. You could do this yourself with just one tool and just see it working. You can also see, I hope you understand what I mean, we could equally have just simply put these decorators directly into accounts.py. We didn't really need the separation. We could have just put the MCP decorators all the way through this and instantly exposed these functions. I just separated out because that's a bit cleaner, and that means that you can apply this to any of your own code to build an MCP server just like that. Okay, if it's really that easy, then we should be able to just use this in our notebook. Let's see if we can. Okay, welcome back to the lab then. We're at week 2, day 2, and we're going to run some imports and the load.env. And now we're going to import account. This is the business logic class. Nothing to do with MCP servers yet. I just want to show you this. When I import it, it automatically creates a new SQL database with SQLite, because that was in the code at the top when you import. If it doesn't already exist, it creates one. And also, if I get an account that doesn't exist, it creates a default account with $10,000 in it, which is kind. So there we go. This is all a simulation, of course. It's just to have something stored so we can watch trading happening. So here we go, new account called Ed with a fake balance of $10,000, no holdings, no trades, no time series. And we're now going to buy 3 shares of Amazon in this fake simulation. And we're going to pretend that I'm thinking of doing this years ago. And my rationale for doing it is because this bookstore website looks promising. Oh, if only I had had that foresight. So there we go. We buy shares, completed. And it gives some details of that, the balance, the strategy. And I should say, actually, there's some code in here that looks up the current share price of Amazon. And later we'll come back and I'll talk about how we do that. Then we are going to ask for a report of the account. And here it is with the strategy, the transactions, the rationale. And over at the end here, there is a total portfolio value and a profit and loss. And you'll notice that the total portfolio value is slightly less than the $10,000 it was originally. And there's a tiny negative profit and loss. And for those that care about this, that want to dig into this, I have made a a small assumption, a fixed assumption of a fee that you pay every time that you trade in the form of what they call a bid offer spread. And you'll see that in the code. It's just a very simplistic assumption to mean that every time you trade, you lose a little bit. Okay, so let's list transactions in our portfolio. We have 3 shares of Amazon at that much each. And that is a quick demo of the business logic. The next step is to use our MCP server and see if we can access this directly through the MCP server. All right, so how hard do you think it will be? It's going to be very easy. So remember this params. Params is how you say what it is that you want to do. What server do you want to run? And literally, the command is uv, and the arguments is run, and then account server.py. It's just going to spawn a process. It's going to do it itself. It's going to run this process, uv run account server.py. Okay, now I have this line async with MCP Server Studio as server. So what is MCP Server Studio? So this is a class from OpenAI Agents SDK. And it's basically some code which essentially creates an MCP client and attaches to an stdio server that you want to run. It will spawn that server and then run it and allow us to do something with it. So all of that is simply in this one class. And as I think I mentioned before, this is actually relatively new in OpenAI Agents SDK. And as of just recently, you would have to do that last part yourself of writing the code that spawns the server. And fear not, we will do that anyway, just so you see that side of it. But you don't need to, because OpenAI Agents SDK has written that for you. So this is the client and spawns that service. And then we are just going to call list tools, just as we did for fetch, for all of the other tools that we used last time. This is the same code. It's just 3 lines. We run it, we get the MCP tools, and here they are. Get balance, get holdings, buy shares, sell shares with a description. And then you'll see if we scroll along that there are going to be all of the different bits and pieces to it. So if we now just remind ourselves, if we go to the accounts server, you'll see here is our MCP server. And so get balance right here was one of the decorated functions from our server. And if we go back here, you'll see that get balance with that description is exactly what has been surfaced here. And so it really is that straightforward. Okay, so we've seen how easy it is to list the tools. Now let's use them. So it really is going to be, again, very straightforward. Writing MCP servers is a little bit of a few extra decorators here and there. Using them is a cinch. So here's some instructions or a system prompt. You are able to manage an account for a client and answer questions about the account. My request, my name is Ed. My account is under the name Ed. What's my balance and my holdings? Model GPT-4o Mini. That sets us up. And so here it is. This is the code. With MCP Server Studio, that is the OpenAI Agents SDK thing, passing in the parameters of our server, caching the tools, why not, as MCP server. We don't need to do this particularly for one call like this, especially to show you how simple the code looks. So we create an agent called Account Manager. We give it the system prompt, the model, and we pass in the server, the MCP server that we want to use, which is our MCP server, our very own homemade one. And then we put in a trace and we say runner.run with the agent, and we pass in our request, and we'll display the final output. The question is this going to work? What it's going to do if it works, it's going to create an MCP client, which will then spawn an MCP server. It will basically call uv run account server.py, launching that process. It will talk to that process using standard input and output, and it will collect the tools. It will pass those tools into our agent by constructing the JSON gumph that will go in. And when the LLM says it wants to use a tool, then this code will then run that using standard input output to ask our spawned process to run that tool. And then the results will come back and be given to the LLM, which will complete. So there is a lot of stuff happening backwards and forwards that's all been elegantly wrapped into this. Will it work? Will we find out our holdings in natural language from asking GPT-4o Mini based on our very own server? Yes, we will. Your current balance is 9,470. In terms of holdings, you have 3 shares of Amazon. That is mission accomplished. So what we're going to do now is create our own MCP client. And this is a bit unusual. It's not actually that common to need to write an MCP client. When would you do it? You would do it if you're building your own application that's going to be a host that's going to be able to call MCP servers. And in your application, you want to be able to call a number of different MCP servers. And so you're going to want to write an MCP client. You'd also have to do this if you rewound the clock a few weeks and wanted to use OpenAI Agents SDK, because they didn't used to have one built into them, but now they do, which makes this not as useful. But I did this the first time because I needed to, but no longer. And if you were using another framework or you were going natively to an LLM and you didn't have a client that you could use, then you would have to do this yourself. And it's pretty straightforward. So we might as well do it. Let's go do that now. So I'm going to go into this module called accounts-client.py, which is our MCP client implementation. And we're using a bunch of MCP Anthropic code from client.standardinput-output. We're importing the standard input-output client. From MCP, we're importing this standard input-output server parameters, which is going to use the parameters in the format that we're used to now. And this is something I'm importing from OpenAI because I want to translate between Anthropic's description of tools for MCP into OpenAI's version for this purpose. So the parameters that we set up is one of these Studio Server Parameters objects is basically the same parameters we were looking at before, uv run accountserver.py to load, to run our server. Okay, and so there is here a list tools function, which is going to create our client, spawn a server, and get it to list its tools. And this is how it works. You use the context manager with to create a standard input output client. You start a session, and then you initialize the session, and then we call this list tools on our session, and we get back the tools. We can also call a tool using this call tool function. We can read a resource, and this is one that we will actually continue to use. We'll use this approach for reading resources. Read a resource, we start the client, the session, and then we call read resource on our server. And so each of these three that you see here, to list the tools, to call a tool, and to read the accounts resource, to read a resource, what they're all doing is they are spawning a Python process. They're calling this, which triggers, which spawns another process. They're connecting to that process using its standard input output. That's how they're communicating. And they're using the agreed MCP protocol as the way to communicate, and to communicate things like list tools and call tool and read resource. That's part of the protocol. That is what's happening. That is how the client talks to the server. And that's really at the root of all this. And that's why I show you this. So you see that's how it all fits together. And then I've got a utility method here, a function, get accounts tools OpenAI, which is going to call list accounts tools. And what comes back, it's in a format that is part of the MCP format. And OpenAI for its tools has a slightly different format, just very slightly different. And so I map between them and I return that in the OpenAI version of things. And this code here, along with this client code, is basically what OpenAI has now written and provides to us out of the box. So we don't need this anymore. But if we wanted to, we could just do it this way, and then we've written our own client. So as I say, not necessary, but it shows you that writing an MCP client is no big deal. You just have to use some of Anthropic's code to spawn a process, connect through its input, output, its standard in and standard out, and then ask questions like, what are your tools? Let me call the tool, and can I read your resources? And so that's all it takes to talk to our server. And of course, these parameters could be anything that you want. So it doesn't have to be specific to accounts. This could just be a sort of generic server that takes care of this. All right. So with that, let's go and give this a try. Let's try using our client. So we're back in our lab, and from that client module we were just looking at, I'm going to import two things: get accounts tools OpenAI the thing we were just looking at, and read accounts resource, another thing that we'd seen that just calls the server for the resource. Let's run this. And if I print OpenAI tools, we'll see there, these are the OpenAI tools. In fact, what I can also do, I can just call the list accounts tools. We can just directly call that as well. Let's just do this to show you. I will say list accounts tools, MCP tools equals await list. There we go. That's what I want. Thank you, cursor. And then we will print those. And so just to show you what this means, if we run this, this first response here is exactly what comes back from the MCP server through our MCP client, printing it. And this second line, the OpenAI version, is just what happens when I switch it up into being in the format that OpenAI expects. But that's the only distinction between them. But either way, making these calls, it started our client, it had that session in it, it spawned a process, it made a call to that process, the standard output was collected and returned right here. And that is an MCP client and server at work. It's also perhaps worth pointing out that the way I've written this is not efficient, that every single call in here is spawning another process. It's running this again, creating another session. In practice, you could do this more efficiently with one context manager that handles all of these different steps. But right now, this doesn't matter to us particularly. Starting this Python process is super quick. So that's not of consequence. But you may have noticed that that's probably not the way you would want to write it if you needed to have this scale a lot. You would just have the one context manager. Okay, so going back to the lab then, let's actually use this client with an agent. And so we create a new agent. The name is account manager. The instructions as our system prompt, the model is the model, and the tools we're passing in, we're no longer passing in an MCP server. We're passing in the tools that we've just reconstituted here. And the thing, and this might be a little bit of a leap, the thing to keep in mind is that within those tools, there is the function to be called. And that function to be called, if the tool needs to be triggered, if I go back to the client, the function to be called that we've set up here, you'll need to look through this code, but it is to call back to this call accounts tool with the tool name in question and its arguments. So the bottom line is that if the LLM chooses to run one of these tools, that's going to end up calling our MCP client, which is going to call our MCP server, which is going to call our business logic for that particular tool. All of that is going to happen, but this time it's going through our MCP client. And so we're still asking the same question. We're asking my name is Ed, my account is under the name Ed, what's my balance and my holdings? But rather than using the MCP client that OpenAI provides us, we've built our own. And let's see if it works. So now going through our MCP client, spawning the MCP server, and we get back the right balance and that I have 3 shares of Amazon. So yes, it works going through our MCP client and server together. And I can also show you what it looks like to read a resource. So it's using the read accounts resource method function that we have in our client right here, read accounts resource, which launches a client and then creates a session with a server. So a Python process will launch to run this code right here, which is going to run our MCP server, which within it imports our business logic. And then we're going to call read resource with Ed instead of name with this, and that is going to go to the server. On the server, it's going to call this read resource function you see right here. And because name is in the decorator at that point, that is how name is going to be provided. That is going to call account.get for the name. Okay, what does that do? Let's go in here. That calls this method get right here, and then it will call report on that. And you can see that the report down here is going to return a string representing the account. So that is the chain of events that's going to happen if it all works when I simply call read accounts resource. And let's see, and there is the result. And now, if you're following all this. If you're not following all this, it doesn't massively matter. The purpose of this is to show you the what goes on behind the scenes, the plumbing behind MCP. If you are following all this, you might be thinking to yourself, hang on a second. Okay, I see this, but surely I can also just say from accounts, import account. I like the way Cursor does that. Account.get from accounts. Accounts.getEd.report. I could just run that and I'll get the same thing. And you're absolutely right, you can. This is a rather faster way of doing it than going through an MCP client, through an MCP server, to launching a Python process, to attaching to its input and output, to making that same call, and to bringing back all of the results. And that's why I say that the magic of MCP is more about how this allows you to share tools and resources across different places. Because if you're just writing it for your own purpose, then this, just writing the business logic and just getting the resource, is an easier way to do it, frankly. The reason you would want to build all of this scaffolding around MCP is because then you've got this consistent, universal USB-C way that anybody can read the Ed's account details just using this interface. And that's the big point. And so for the exercises, to wrap it up, a couple of them here. Make your own MCP server. There's something you can do that's really simple. You can make a Python function to return the current date, expose it as an MCP tool, bring it into an agent and ask the agent the current date and make sure it works all the way through. It's easy to do, and it's really nice to show you to connect the dots. And then optionally, if you wanted, you could put an MCP client on top of that as well. So you can go through an MCP client. And then what you could do is use a native approach for calling OpenAI's code directly, just as we did in week 1. Go through and make the JSON stuff and use the handle tool calls and see it working that way through your client and server. So you're not taking advantage of the stuff that comes with the OpenAI Agents SDK. And then you will really have seen, you'll have connected the dots all the way through to what's going on behind the scenes. But that's an optional exercise. If you get it, you don't need to do that unless you really want the gory detail. But hopefully this lab has helped you to understand how things work behind the scenes and what it is that MCP is so good at, and where you perhaps don't need it as much. Well, with that, we've built an MCP server, an MCP client, and we've used it with an agent, and it was great. And I hope you now have a pretty decent understanding of how to connect the dots. Next time, we're just going to go crazy and use a bunch of local and remote MCP servers to get into this and to enjoy the ecosystem. I will see you then.